Sri Gurubhyo Namaha. Welcome to our online teaching academy, Ekaleva. Today my topic is optics. In this optics, we are going to discuss about refractive index. So we should know what is refractive index. So refractive index is nothing but it tells about the how fast or slow light travel in a medium. That is we called as a refractive index. So refractive index is defined as ratio of speed of light in a vacuum to the speed of light in a medium is defined as a refractive index. Defined as a refractive index. So in this refractive index we denoted as a mu. It is represented as a mu. So refractive index is responsible for to change the velocity of light in a two medium. The point is the speed of light in a medium is low. When it is low, if the refractive index of the medium is high, and similarly the speed of light in a medium is high, which means when it is high, when the speed of light in the medium is high, which means the refractive index of the medium is low, then only the velocity of light is high. So that means, velocity of a light is fully depends upon the refractive index of the medium. For example, the light comes from the rarer medium to denser medium. So in a rarer medium, the velocity of light is higher than the denser medium because of the refractive index of the air medium is lesser. That's why the velocity of light higher in that rarer medium compared with the denser medium. Next point is, see this image, I am consider here when the light comes from rarer medium to denser medium. So rarer medium is nothing but a air medium. Denser medium I am going to consider here as a glass slab. Now the light comes from the source, fall on the interface of the two medium. Interface of the two medium. So the light get deviated in that medium. See this light, the light is deviated in that medium itself. This is called as refracted ray. In this refracted ray is towards a bend, towards a normal. So because of this refracted ray tells about the light comes from the rarer medium to denser medium. Then only the deviated ray shows towards the normal, bend towards the normal. Again see this image here. So now the rays comes from denser medium to rarer medium. So denser medium is that glass slab to air medium. The ray gets deviated. The ray gets deviated. This deviated ray I am going to call it as a refracted ray. But this ray is away from the normal. So this deviated ray shows that the light comes from the denser medium to rarer medium. That's why the refracted ray bend away from the normal. Bend away from the normal. Next one is refraction of composite light. First one is, we know very well the sun is the basic or primary source of light. So we know that the sun is the fundamental and natural source of a light. So in this natural source of light produces the light of single color. The source of light which produces the single color, we call it as a monochromatic source. We call it as a monochromatic source. because it will have a ability to produce a single color. That's why this called as this source, this types of source we called as a monochromatic source. Example is sodium vapor lamp. Example, sodium vapor lamp. Suppose in order to produce, the source of light produces a light of different colors, or we can say produces the multicolors, means that source of light we call it as a polychromatic source, because they have a ability to produce a multi or different colors. That's why we called as a polychromatic sources. So who are all, which sources which produces the different colors means, that is white light or mercury vapor lamp or sunlight. So these are the capability to produces the multicolors. So example is sunlight. Sunlight consists of composite light. It contains different colors and then wavelength. And the same way mercury vapor lamp. So mercury vapor lamp is also called as a composite light, because of this one also produces the different color and then wavelength. Next one is dispersion of light. So what is dispersion of light? Let's see. When a beam of light or composite light, so we know very well, so beam of white light. So white light is nothing but it contains different colors in it. It contains different colors in it. And composite light otherwise called as a polychromatic light only. When a beam of white light or composite light is refracted through any transparent medium such as glass or water, it is splitted into the components colors. The components colors example is 7 primary colors, splitted into 7 primary colors. So this phenomena is called as dispersion of light. So see this example here. When the light is incident on the glass prism, when the light is incident on the glass prism, the light gets deviated from the incident ray. It produces the different colors in it. It produces the different colors. So the different colors we called as a spectrum, or the band of colors we called as a spectrum. This type of different types of colors we called as a spectrum. Okay. In the spectrum consists of 7 primary colors. I said no. What is that? Violet, indigo, blue, green, yellow, orange, red. These are the 7 primary colors produced from composite light. So that's why this one we called as a spectrum. So this one otherwise we called as a VIBGR. In a short form we called as a VIBGR. VIBGR colors. So the composite light produces the VIBGR colors. When it is produced the composite VIBGR colors, when the light is fall on the any transparent medium, that is mainly the composite light fall on the any transparent medium, then only we are getting that spectrum. Is the main question. Why do we get the spectrum when white light is refracted by a transparent medium? So answer is the different colored lights. So different colored lights have a different wavelength and a different angle. So that's why we are getting the spectrum from the transparent medium because of composite light. So different colored lights are bent through the different angles, that is the angle of refraction is different for different colors. That's why we are getting that spectrum. Is an important note. So angle of refraction is the least for red and highest for violet. So what is the angle of refraction means? See this diagram. When the light incident on the glass prism, this is the actual path of the light. this will be the actual path of the light. But this is not happened here because of when the light is incident on the glass prism, it gets deviated or it bend in that medium. So in this way we are getting that spectrum we know very well. So see this, so angle of refraction is higher for violet because of, I am going to calculate here, so angle of refraction is higher for violet. But the angle of refraction is lower for red because of this one is nearer to that angle of incidence. Red is nearer to the angle of incidence, so that angle of refraction is smaller for red and higher for the violet. Next one. So refractive index of the medium is different for different colored lights. So each and every color have a different wavelength. That's why in same way the refractive index also changed. So each and every color have a different refractive index, depends upon the wavelength. So the refractive index of the medium is depend on the wavelength of the light. To receive our online lesson, please press the subscribe button and you will receive the latest update. Thank you.
SRMJV is not just a school, it's a one-time experience.
VM Nagar, Tiruvallur,